Carbon upcycling technologies is basically based on a chemical adsorption process. So basically what that means is we take low-grade carbon, something like graphite or coke or coal, and we create surface area on that so that it absorbs CO2. So sort of the analogy that we've always tried to use is like a piece of cheese. So usually you think about it having holes. You know, that's kind of the stereotypical piece of cheese, but think about the piece of cheese in our process being a monolith, like with no holes going in. But when it comes out of the process, it's got all these little holes which are now entrapping CO2. What we've spent a lot of time on in the last couple of years is proving that that's stable capture. So it's not that, you know, you move that piece of cheese or the graphite or the coal in our instance around and that CO2 just over time releases back to the atmosphere. And what we found is that it's actually stable up to 2 times the boiling point of water. So up to 200 Celsius, which is quite stable. The more interesting part of the technology is people have looked at adsorption for hundreds of years. I mean, we've used it actually for thousands of years as humanity. But when it comes to the CO2 challenge, in the last few decades, everyone has always had a step where you release the CO2 back because, you know, the piece of cheese with that CO2 in it, no one wants that. And what's different about our process is that you can actually use that filler with the CO2 in place as a reinforcing agent for polymers, so plastics, for concrete products, as well as for asphalt and coatings. In fact, just about a month ago, we were in Portland, Oregon, where we installed a coating for a precast company. Where, you know, the coating had our carbon in it and it had some of the CO2 that we captured in it as well. It's not a huge amount of product that they needed. They only needed 20 gallons of the coating, but it was a start and it proves that it can be done.